Have you ever stopped to wonder why the sky is blue or where rainbows come from? It's time to awaken your inner explorer as we embark on a journey through the extraordinary world of nature. Unleashing the secrets of the blue sky, the spectrum of rainbows, the enchanting northern lights, and the symphony of singing whales. We'll delve into the intriguing science that makes our world a spectacle of wonders. In the next few minutes, we're going to unravel some of these mysteries. Are you ready? First, let's delve into why the sky appears blue to us. Now, you might think it's a simple answer, but the truth is much more fascinating. It's a result of a particular type of scattering called Rayleigh scattering. But hold on, what is scattering, you might ask? It's when light bounces off particles in the atmosphere, and the blue light is scattered more than other colors because it travels in shorter, smaller waves. This blue light is then scattered all around the sky. But why blue, you might wonder? Why not green or red or any other color on the light spectrum? That's where the wonder of our eyes comes into play. Our eyes are more sensitive to blue light and less sensitive to violet light. Additionally, sunlight reaches us more from the blue part of the spectrum rather than the violet. However, it's not just about the scattering of light and the sensitivity of our eyes. The time of day also influences the color of the sky. Have you ever noticed that the sky tends to be a deeper blue in the middle of the day, and a lighter blue in the early morning or late evening? That's because the sun is at different positions in the sky. When the sun is high, the blue light is scattered in all directions and the sky appears blue. But when the sun is setting or rising, the light has to pass through more of the Earth's atmosphere, and the colors with longer wavelengths such as red and orange are scattered, and we see a beautiful sunset or sunrise. So it's not just a simple "the sky is blue" answer, it's a beautiful dance of physics, light, and our perception. It's about how sunlight interacts with our atmosphere, how it scatters, and how our eyes perceive this scattered light. So next time you look up, remember it's all about light, scattering, and perception. Now moving on to the colorful arches that appear in the sky after rain, the rainbows. Have you ever wondered how these vibrant bands of color come to life? It's all thanks to a fascinating play of light and water droplets. This beautiful phenomenon is the result of refraction, reflection, and dispersion of sunlight, all happening inside a tiny raindrop. Let's break it down. It all begins with a simple ray of sunlight. As the light approaches a raindrop, it slows down and bends, or refracts, as it enters the water. This is because light travels slower in water than in air. Next, the light ray reflects off the inside surface of the raindrop. This is the reflection part. But it's not over yet. As this reflected light exits the raindrop, it slows down again and refracts once more. This time it splits into different colors. Each color of light bends at a slightly different angle, creating a spectrum of colors. This is dispersion. Now imagine this happening in countless raindrops at once, and voila, you have a rainbow. The colors you see in a rainbow from the top to the bottom are red, orange, yellow, green, blue, indigo, and violet, often remembered by the acronym ROIG-BIV. But here's a fun fact. While we usually picture a rainbow as a half circle, it's actually a full circle. Yes, rainbows are complete circles. However, from the ground, we usually only see the top half because the Earth's surface obscures the bottom part. And remember, each person sees their own personal rainbow, as the appearance of a rainbow depends on the viewer's position relative to the sun and the raindrops. So, your rainbow is uniquely yours. So, a rainbow is not just a beautiful spectacle, but a wonderful demonstration of the physics of light. Ever heard of the magical northern lights? Wonder what they are? Well, let's dive into the grand spectacle of nature that illuminates the polar skies, the aurora borealis, or as we commonly know them, the northern lights. Imagine, for a moment, a large curtain of light dancing across the night sky. These lights, a fantastical array of greens, blues, yellows, reds, and even purples, are a sight to behold. But what causes this mesmerizing light show? Is it magic? Is it an alien light show? It's actually something even more fascinating. Everything begins with our sun, the bright star at the center of our solar system. The sun constantly throws out a stream of charged particles known as the solar wind. This solar wind travels across the vastness of space, and when it reaches Earth, something truly magical happens. Our planet is protected by a magnetic field, a sort of bubble that shields us from harmful solar radiation. When these charged particles from the sun collide with the Earth's magnetic field, they are guided towards the poles, the north and the south. As these particles descend into the Earth's atmosphere, they collide with different gases. It's these collisions that create the vibrant colors we see in the northern lights. Oxygen gives off green and red light, while nitrogen produces blue and purple hues. But the dance of the northern lights isn't just a spectacle for our eyes, it's also a testament to the sun's power and the Earth's protective shield. It's a visual reminder of the complex and beautiful interactions happening in our universe every second. So when you gaze up at the night sky, and if you're lucky enough to witness the northern lights, remember, you're not just seeing a light show, you're witnessing solar particles and Earth's magnetic field in a celestial dance, creating a symphony of colors. Isn't that something? So, the northern lights are not just magic, but a celestial dance of particles and magnetic fields. Now let's dive into the ocean and listen to the symphony of the whales. In the vast expanse of the ocean, whales use their voice as a beacon, illuminating the depths with their melodious calls. But these aren't just random sounds. These are intricate songs with distinct melodies and phrases, structured much like the music we create. Whales sing primarily for two reasons: communication and mating. In the oceanic abyss, visibility is limited, and sound waves travel faster in water than in air. So whales have adapted to use sound to communicate. They produce a wide range of vocalizations, from clicks to pulses to long, complex songs. Each song is unique to an individual or a pod, much like a personal signature. They use these songs to convey messages, to navigate, and even to hunt. But there's more to these songs than just practical communication. Male whales, particularly humpbacks, are known for their enchanting songs during the mating season. These songs can last for hours, and they are constantly evolving. It's a performance, a serenade, aimed at attracting a mate. The longer and more complex the song, the more likely the male is to attract a female. Interestingly, these songs can travel incredible distances, up to hundreds of miles, resonating through the ocean. This means a whale's song can reach a potential mate even if she's far away. It's a testament to the power and reach of these mesmerizing marine melodies. But remember, these songs are not just about communication and mating, they are also about survival. The ocean is a vast and challenging environment, and for whales, their songs are their lifeline, their way of connecting with each other, finding a mate, and navigating their world. So, the next time you hear a whale song, remember it's a complex language in the marine world. Well, there you have it, a quick journey through some of the most fascinating natural phenomena. We've explored the azure expanses of the blue sky, a sight so commonplace yet laden with intriguing scientific facts. We've delved into the vibrant spectrum of colorful rainbows, a testament to the playful interaction between light and water droplets. We've marveled at the ethereal beauty of the dancing northern lights, a spectacular light show staged by the forces of the universe itself. And let's not forget the enchanting melodies of the singing whales, a symphony from the depths of the ocean that speaks volumes about the complexity of these gentle giants' communication. Each of these phenomena, as we've seen, is a product of the intricate and delicate balance of nature. These are not just fascinating sights and sounds for us to enjoy, but also reminders of the awe-inspiring complexity of the world we live in. They serve as a call to appreciate and respect the grandeur of nature, to understand its workings, and to strive to preserve its marvels for generations to come. Every day, nature presents us with a myriad of wonders, each more captivating than the last. All it takes is a keen eye and a curious mind to uncover these treasures. So let's not stop here. Let's continue to explore, to question, and to learn. Remember, nature is full of wonders waiting to be discovered, so keep exploring and keep learning. Until next time.